We're going to look at the sums, differences, products, and quotients of functions. Here we have the function of a sum is equal to the sum of two functions. What we mean to say is that we can take two functions and add them together in order to create one function that is the total. For an example, let's see I had f of x is equal to 3x, and I had g of x was defined to be x squared plus 1. And I wanted to know the sum of these two functions as one function. So I could say that f plus g of x is equal to f of x plus g of x. And all I'm doing here is copying down my rule. I'm going to substitute f of x for 3x, and I'm going to substitute g of x for x squared plus 1. So together now we have this new function f plus g of x is equal to the function x squared plus 3x plus 1. On the same deal, we can subtract two functions. So the difference of two functions is equal to when we subtract these two functions. And so I can actually use the same f of x and g of x in the same example I did before. I can say f of x is equal to 3x, g of x is equal to x squared plus 1. And now when I subtract these two functions together, this is going to be 3x minus, make sure you use a parenthesis here so that your distributive property will apply later on when we combine these terms. So this ends up being 3x minus x squared. This negative distributes to the 1. That's going to be minus 1. I'm going to put my factors in descending order of degree. So that's going to be minus x squared plus 3x and then minus 1. Same holds true for multiplication. The function of a product is equal to the product of two functions. Let's try some different ones here. Let's try x cubed, and let's do g of x is equal to x plus 1. Now I'm going to say that f times g of x, I'm putting a dot here, that's indicating multiplication. We don't have to put it here, I'm just putting it here for clarity. F of x from my definition is x cubed. G of x is x plus 1. And then here I multiply these out using the distributive property, and this becomes x to the 4th plus x to the 3rd. And that's going to be f times g of x. Lastly, we have the function of a quotient is equal to the quotient of the functions. Here I can say f of x is equal to 2x, and let's say that g of x is equal to x plus 12. When I want f divided by g of x, that's going to be equal to f of x divided by g of x. I'm going to do 2x divided by x plus 12. Now here we have to check our domains. And our domains here are very important. Our domain here for f of x was all real numbers. Our domain here for g of x was all real numbers. But when you combine these two functions together and you divide one from the other, we have to make sure that you're not dividing by 0 in our denominator or performing something otherwise that would be illegal in mathematics. So we need to make sure that x plus 12 does not equal 0. Solve this little mini equation here by subtracting 12 from both sides, and we're going to get x is not equal to negative 12. So we need to make sure that we have this restriction on our domain when we combine these two functions together using this quotient rule.